This is Mrs. Davis. This is AP Pre-Cal. We are working on Unit 3B review, and we are ready to start number 15. Okay, and we're still on the same directions to solve these trigonometric equations. So if I look at number 15, and always take a second to look, I don't have a sine and a sine. I have a sine and a cosine, so I'm not going to use a quadratic pattern. And I need to get the same trig function, like sines are all cosines. And I do know that if I use the Pythagorean identity, that I can say that that sine squared x plus cosine squared x equals 1. So I can rewrite sine squared x as 1 minus cosine squared x, and then maybe I can use the quadratic pattern or something like that. So I'm going to rewrite sine squared theta as 1 minus cosine squared theta is 2 cosine theta plus 2. So now let's get everything on the same side. 1 minus cosine squared theta minus 2 cosine theta minus 2 equals 0. So I would have negative cosine squared theta minus 2 cosine theta, and then just 1 minus 2 would be minus 1 equals 0. Well, we have everything negative, so let's turn it over on the other side. So cosine squared theta minus plus 2 cosine theta plus 1 equals 0. So we're going to let a equal cosine theta. So I have a squared plus 2a plus 1 equals 0. So we have a plus 1 quantity squared equals 0. So now we can put back that we have cosine. What did we make? We made u cosine. So cosine theta plus 1 equals 0. So cosine theta is negative 1. And the only place cosine theta is negative 1 is at pi. So the answer would be theta is equal to pi. Now this next one, there was an error in the problem. When I started to do it, I was like, it didn't factor. So this is supposed to be plus 3. So change that to plus 3. So if you have, let's just get everything on the left side if we're solving a quadratic. So 2 sine squared theta minus 5 sine theta. This would make it minus 3, which is what I need, equals 0. So let a equal sine theta. So we have 2a squared minus 5a minus 3 equals 0. So that would be 2a and a, and this would have to be a minus 3 and a plus 1. So yeah, that would give us minus 6 plus a 1a. So that's equal to 0. So now that we've changed that error, we can say that 2 cosine theta plus 1 is 0, and 2 sine theta minus, or just sine theta minus 3 is 0. So sine theta is 3, nowhere. Sine theta is negative 1/2 at theta is negative in quadrants 3 and 4. So this would be 7 pi over 6 and 11 pi over 6. So theta is 7 pi over 6 and 11 pi over 6. Okay, let's go on to number 17 through 19. It says find an interval that will satisfy the inequality on the given interval. Okay, so we got to have sign charts, and notice this is also calculator time. So if we look at how we're going to do this, we want it to have 0 on the right-hand side, so we're going to say cosine of x minus pi over 4 minus cosine x as be greater than or equal to 0. So we're going to put this in our calculator as y1. And then we're going to graph it and look for the zeros. So we're going to graph it and find the zeros. So look at your calculator and find the zeros of that function, and then let's write them out in a sign chart. So we have at the first zero was at 0.392699 dot dot dot, and we have another one at 3.53429117. Make sure you have that. And we're going from 0 to 2 pi, so we stop there. So it's negative before that 0, and then positive, and then negative after. So where is it greater than 0? It would be in the interval from here to here. So that's the interval 0.393, we're rounding, to 3.534. Okay, same thing coming over to number 18. They want where this function is less than or equal to 0 from 0 to 2 pi. So we're going to put in y1 is going to be this sine of x plus 1/3. And then we're going to find the zeros. We're going to graph it first on our calculator. We're going to find the zeros. And let's see, I have a 0. The first one is at 3.4814296, and then I have another one at 5.9433484. So then there's 2 pi. This is 0. And so it is positive before then negative, then positive on the graphing calculator. So it wants to know where it's less than or equal to 0. So less than or equal to 0 would be between here and here. So 3.481 to 5.943. All right, so that's how you do those. All right, and lastly, let's look at number 19. We have a function given, h of t, where the number of hours of daylight, on any day t of the given year. So they're using 365 days for the year. In Southern California, can be modeled by this function. Okay. It says find the interval where the region will have at least 12 hours of daylight. So that means if h of t is the hours of daylight, then h of t has to be greater than or equal to 12. So if we say 2.42, the sine of 2 pi over 365, t minus 80, plus 12 has to be greater than or equal to 12. And so solving for 0, those would go away. So you're just looking on your calculator. So let's put y1. We're going to see where it's greater than 0 now, right? Greater than 0. So put y1 in your calculator as 2.42 times the sine of 2 pi over 365 times t minus 80. And where do you get your zeros? So I'll give you a hint. Let me put the hint here about the window, because we got 365 days. So your x should change your x on the window to 0 to 365. And you should get a graph, that looks like, this. And it'll have 2 zeros. So if it needs to be at least 12 hours, you're going for this area where it's above the 12. So it's above the 0. Sorry. We will go and see that this was 80, this point on the graph, and this point was 262.5. So from day 80 to day 262.5, or 80 comma 262.5 if you put it in interval notation, a hard bracket, because it's at least 12 hours. So greater than or equal to 12. Okay, let's look at B. The summer solstice is where the maximum number of hours of daylight occur. Find the day and the number of hours of daylight to the nearest tenth of an hour. Okay, so now we need to find the maximum, right, from our graphing calculator. And we need the x and y values. Now, our graphing calculator does not hold h of t. Remember, we set it greater than or equal to 0. We subtracted out the 12, right? So watch out. You've got to put h of t exactly in. So y1 would be h of t, the full function h of t. So put that in as y1. And now you're looking for the maximum. Now, you got to change your window again here because there's 24 hours in a day. So you've got to go, you keep your window x 0 to 365, but y make it 0 to 24. And then you'll have the y value because the y value is the number of hours in the day. And so you should get a graph, like this. And so you're looking for the maximum x and the maximum y. So the number of hours of daylight would be the y, and when it occurred would be the x. So it says where the maximum number of hours find the day and the number of hours. The number of hours to the nearest tenth of an hour. So if you go pull that max, the max occurs at x equals 171.250. So day 171.250. So it has to occur in day 172. And then the number of hours would be y, which is 14.42. So day 172, or they're not going to mark it wrong if you say 171.250, and then and the hours is 14.4 hours of daylight. So at day 172, there's 14.4 hours of daylight. Okay, and when does the winter solstice occur? How many hours of sunlight will there be on the day? All right, so you've got to figure out the minimum. So the minimum should occur at day, if you look for the minimum, 353.75, and the number of daylight hours is 9.58. So your interval, or here your xy would be 353.75 and 9.58. But let's answer it where we say day 354 with 9.6, approximately 9.6 hours of daylight. All right. So there was numbers 15 through 19.